So let's make it more concrete. Okay? So let's make y as some probability function. And it is a function of x. So this is probability, right? And x. And its computation is a function of x. And then we can graph the curve of this function here, right? So x is here and y is here. Y is the probability of y equal to 1. So it does not have to be a binary regression model. It could be a ordinal regression model or multinomial regression or any other kind of probability model when y is a discrete variable, right? So we have this curve, and our job, let's say right now, is to compute the effect of x on y at this point. So if we're going to compute the marginal effect at this point, what we're going to do, we draw a what? Tangent line. Crossing that point. The slope for that tangent line is the marginal effect, okay? And so we focus on this line, this point, right? Then if you recall the definition for a marginal effect, that is a ratio of delta y over delta x when delta x approaches 0, right? But let's assume it does not approach 0. Let's say we set delta x to be what? To be 1. So we increase x by 1 unit. What is the amount of change in y? Well, that is a rise, right? That is the rise on this tangent line, Okay? So we can take a ratio of the vertical distance here over the horizontal distance here in x. And that should be pretty close to, right? That should be pretty close to the marginal effect. Or that is equivalent of marginal effect. Okay? That is equal to the marginal effect. What about discrete change? Well, discrete change is the amount of change in y over the amount of change in x on this curve, okay? So we say if we change x by 1 unit, so from here to here, okay? Or from here to here, okay? To be more convenient. What is the amount of change in y? Well, for y, we increase from here to what? To here, right? So this is the amount of change in y. We can take a difference, take a ratio, and that becomes what I call discrete rates of change. Right, for 1 unit. Because sometimes it could be 2 units or 3 units changing x, right? Or amount smaller than 1 unit change in x, okay? And the thing here is they're different. The discrete rates of change and marginal effect here at this point is different. And they're usually different. The discrete rates of change, as well as discrete change and marginal effects, they're usually different, even at the same location. So here we're talking about the same location. Okay? Why? Because marginal effects vary across places on the curve of a function. Okay? And in most cases, discrete rates of change as well as discrete changes are different from marginal effects for what? For non-linear models, which is not the case, okay, in linear models. In linear models, they're equivalent.